Welcome. In this video, we will learn how to calculate basic probabilities from a summary table. Keep in mind this is summarized data from a larger set of 1,000 houses that we happen to collect. First thing I'm going to do, so that I can keep the screen nice and big, is go to View in Excel and Freeze Panes. This will allow me to scroll down as I continue to add work, but allow us to see the summary table at the top. So the first question I'm going to ask, what is the probability that the color of a house, if randomly selected from the 1,000 in our population, or our sample, is brown? This is called a marginal probability because we get the values from the margin of the table. Here it would be 229 divided by 1,000, or 0.229. Now, as I've been doing, I will copy that formula to the cell to the right. And then I will recreate that cell as a decimal form. The next question is, what is the probability that the house is not in the central area? This is called a complementary probability because we want all the houses but those in the central area. Here, we start with 1 and then subtract out the probability for central, which is 562 in C6 divided by E6, 1,000, and that's 438. Again, I will put the formula in the cell to the right by adding and subtracting an apostrophe in front of it. The next probability is the probability that the house is yellow and in the south region or area. Here, we're looking for the intersection of south and yellow. So that value is 48 in D5. Then, of course, we divide that by 1,000. At this point, we're always working with values out of the grand total. The next question is a little bit tricky in that I ask it from the point of view, what is the probability that the house is in the north and south region or area? Well, that can happen. House can be in two different regions, particularly the north and the south when there's a central in between. Although there's an interesting house in Canada that straddles two countries, that's been an interesting point of contention in the news. So here I'm going to put a little asterisk next to that because we want to list that type of probability as what is often referred to as mutually exclusive. This means that both those individual events of north and south cannot happen at the same time. Excuse me. The next probability is the probability that the house is either blue or in the central region. This is called the general addition rule, and it's tricky in that we have to take into account three pieces of information. First, I'm going to start with a parentheses, and I'm going to take our first condition, blue. So there's 191 blue houses in E2. I'm going to add to that all the houses in the central region, which is 562. But then I must subtract out the intersection of blue and central. Otherwise, I would double count them. And of course, we still divide it by our grand total. Now, if you think about it, it's not too difficult to calculate those just by adding up, all the values in the north and the central, and that's one way to do it. But if the table gets much bigger, that calculation could be cumbersome and prone to making an error. Our next set of probabilities are called conditional. So we first ask the question, what is the probability that a house is brown given that it's in the north region? Here, we restrict ourselves to just the houses in the north region, and then we figure out what the probability that it's brown. So here the formula looks like only the brown houses in the north region, and the big difference is divided by the total houses in the north region. And perhaps I can narrow those decimals so that we're consistently having 3 decimal places. And I'll do my usual formula calculation, or display I should say, to the right. And so the probability that a house is brown, given that it's already in the north region, is almost 18%. Now we flip that for our final probability in this video, where we want to find out what the probability that a house is in a central region, given that it is white. This is no different than what we did before, except this time we're restricting ourselves to just the white houses, and the denominator in this case is not 1,000, but 358. So here we start with the houses in central divided by the houses or the total houses that are white, and that gives us a probability of, let's narrow those decimals, about almost 56%. And so there you have the most common types of probabilities that are calculated off of a summary table. Thank you.